So in this short video, we go over additional examples dealing with conditional probability. Well, let's first of all define conditional probability. So the probability that a second event B occurs given that a first event A has occurred, it's obtained by dividing the probability that both events occurred, in this case the intersection, that's how we denote it, by the probability that the first event occurs. Okay, so in this case we're going to find probabilities in which we look at a second event provided some first event or given or assume some other event already occurred. Okay, and this is how we denote that quantity. That's how we read it, PB bar A. So that's how we write it, but we read it B given A, or event B occurring after event A has already occurred. Or simply, we can also read this probability of B given A. So many different ways to express this. So I'm going to go back to the rolling a die problem. Alright, so we're going to look at the probability of obtaining a green 4 provided a sum of A occurs. Okay, so first of all, let's identify which one is A, which one is E. So whatever is after the word provided or given that or assume that, that's going to be our event A. I'm going to highlight the word provided as well, and that's going to be our event A. The other event will be the event B, which I will use highlight green 4. Obtaining a green 4 given the other event. Oops, this is B. Okay. All right. So how are we going to... Well, first of all, let's set up our event A, which is sum equals to 8, and B, which is green 4. I'm going to highlight all possible outcomes for sum equals 8. I'm going to use the same color, the number 8, the number 8. And for obtaining a green 4, I'm going to use blue. So green, and it has to be a 4. Notice there is an overlap already. Okay, so how are we going to find this probability? So let's write down the formula first. The probability that event B occurs given A occurs, it's going to be the probability of the intersection, in other words, the overlaps, divided by the probability that the first event occurs. Okay, so how many overlaps do you see? Do you see there's only one? So it's 1 out of the total possible outcomes, which is 36. And then I'm going to divide that by the number of eggs that we have in this case. 5 out of 36. All right, so if we simplify this fraction, notice how the 36 are going to go away. So I'm going to have only a 1/5. All right. Okay. The probability of obtaining a sum greater than 9 given that a 4 green is rolled. So event A is whatever is given that, in this case, green 4. So the second event, which is what we want to investigate here, is sum greater than 9, not greater than or equal. Be careful with that. So it's just greater than 9. All right, so let's highlight event A, which is green 4. So I'm going to use like this, and sum greater than 9, which in this case it's all these outcomes. All right, now I'm gonna do this a little bit different than what I did before. The probability of B given A. So instead of dividing this by let's see. Oh, instead of dividing the two fractions and come up with a complex looking fraction, this is what I'm going to do. In the numerator, I'm going to write the number of overlaps, which is 10. Well, it's actually one overlap. Never mind. I was looking at the number 10. It's only one overlap. Okay, let me denote it this on the following way. Number of overlaps. And in the denominator, I'm going to write the probability that the first event occurs. In other words, how many do I have shaded in blue? In this case, is a total of 6. And that's all we do. It's only 1/6. Again, if you want to do it the other way, notice how the 36 are going to cancel. If you want to do it that way, it's fine. Let's do a couple more examples. So the probability of obtaining a sum less than 7 provided a green 2 is rolled. So A is the provided that, which is green 2. And B is the sum less than 7. So green 2, which is in pink, green 2 is going to be the second column, and sum less than 7, which is all this. Alright, so the probability that B occurs, provided A happens first, is going to be the number of overlaps in the numerator, which is 1, 2, 3, 4, over the probability that A occurs. In this case, how many do we have? So A, which is a 2, so in this case there's a total of 6. 1, 2, 3, 4, 5, 6, which is the event I have in pink. Reducing this to lowest terms, we get 2/3. Probability of obtaining a green 2 is rolled, provided a sum less than 7 occurs. So event A, sum less than 7. Okay. And B, green 2. You might notice something interesting about example D and example C. They are both the same events, but in this case the events are reversed. Let's see how is the probability of that changing when we reverse the order of the event. So for letter A, which is going to be now my sum less than 7, the shades are going to be, okay, not these ones. Let me disregard this one. Disregard. I only meant to shade these guys right here. Let me see if I can fix it with wipeout. And let me put 7s manually. Okay, those are the 7s. Alright, so that's sum less than 7 and green 2, which I'm going to use blue for that. Notice the shadings look exactly the same, but different color because of the order of the events is now reversed. So now I'm going to find the probability that event B occurs given A already occurred. So in the numerator, I'm going to have the number of overlaps, which is going to be how many? 4, and the probability of event A, which is sum less than 7, and all the outcomes whose sum is less than 7 are the ones that are highlighted in pink. So there's a total of 5 plus 4 is 9 plus 3 is 12 plus 2 is 14 and 1 is 15. Okay, again this is overlaps, and the denominator is the successes for the first event. And the last example, it's going to be, well, probability of obtaining a green greater than 4 provided a sum greater than or equal 8 occurs. So let's define the event A, which is a sum greater than or equal 8, and B, green greater than 4. So let's highlight sum greater than or equal 8. So the sum is 8 or greater. That's our first event. On the other hand, green greater than 4, not 4 only, 5 and 6. Let's highlight that. Green greater than 4. So let's find the probability, the conditional probability for this P of B given A. So the overlaps in the numerator, how many overlaps do we have? If we count them all, we have 1, 2, 3, 4, 5 plus 4 equals 9 overlaps. And in the denominator, all the pink ones, that is all in the first event, which is 15 again. Okay, if you want to annotate, you want me to annotate this again, this is overlaps and successes in the first event. Again, let me do it the other way. P of B equals A. It's going to be the probability of the intersection, basically the overlaps, which is nothing different than what I did above. Probability of the first event. So again, how many overlaps do you see? That's 9 out of 36 divided by 15 out of 36. Do you see how this go away? We get the exact same thing. The most important thing here is that you get familiar with how the conditional probability works. And if in case you don't want to use the formula, it's overlaps over successes for the first event. Okay, so this is the end of this short video. I'll see you in the next one.